To solve an absolute value equation, something with an absolute value in it, there's a couple of cases to consider. If this value is positive, there's two solutions. If it's 0, there's only one solution. And if this is a negative number, there are no solutions to the equation. It's obvious to see why if you look at a couple of really basic examples. Like starting here, the absolute value of x is equal to 5 definitely has two solutions. You can just kind of guess and check. If you put 5 in place of this x, the equation is definitely true. But if you put negative 5 in place of x, the equation is also true. So that is x equals 5, x equals negative 5 are the only two solutions to this equation. So if you have the absolute value equals a positive number, you can get rid of the absolute value just by writing these two things down. If you compare that to the absolute value of x is equal to 0, there's only one number that makes this true, and that is x is equal to 0. Whereas in this last case, if you have the absolute value of x is equal to a negative number, the way we define absolute value, it's always positive. There's no way this could ever be true. And because of this, there is no solution. We're mostly going to focus on what's happening over here, where we have the absolute value is equal to a number. And what we're going to do is break it down from an absolute value to two separate equations. Before we move on, I want to point out a common mistake that happens when solving these equations, and it's what's happening down here. The absolute value of x minus 5 is not equal to x plus 5. You can't just take this negative and make it positive because we're dealing with absolute value. The reason you can't do this is x minus 5 might be positive or it might be negative depending on what goes in place of x. So you can't just simplify the expression this way. You could also verify this by just checking a number. Like you could say, well, what if x was equal to 10? Is the absolute value of 10 minus 5 equal to 10 plus 5? And the answer is going to be no. The absolute value of 10 minus 5 is the absolute value of 5. The other side's equal to 15. And 5 is definitely not equal to 15. So the point of this being, you have to be careful when working with these equations. To solve an absolute value equation, we need to get rid of the absolute value, but this is not the right way to do it. So how do we solve an absolute value equation? Like this one, the absolute value of 2x minus 7 is equal to 15. What we're going to do is ask ourselves, what would I put inside the absolute value to make this thing a true statement? And there's two possibilities. If the thing inside the absolute value is equal to 15, the absolute value of 15 is equal to 15. Also, if the thing inside the absolute value was equal to negative 15, that's going to be a solution as well. Here are the two equations we're going to set up. If 2x minus 7 equals 15, that must be a solution. But also, if 2x minus 7 were equal to negative 15, that's a solution too. All we're saying here is, if you put 15 here, it gives us a solution. If you put negative 15 here, it gives us another solution. All we need to do now is just solve these two equations. I'll start with this one. To get x by itself, I'm just going to add 7 to both sides. I get 2x is equal to 22. I'll then divide both sides by 2. And I get x is equal to 11. Solving the other equation is going to be extremely similar. So I'm still going to add 7 to both sides. But this time, I get 2x is equal to negative 8. And when I divide both sides by 2, I get x is equal to negative 4. I think it's worth checking to see that these are in fact solutions to the equation that we started with. So let's plug those in. What's going to happen is, if I put 11 in place of x, it'll give us 15 inside the absolute value. So let's see. That's the absolute value of 2 times 11 minus 7. Is that equal to 15? Okay, so that's 22 minus 7 in absolute value. And 22 minus 7 is the absolute value of 15. And yeah, 15 is equal to 15. Perfect. Now, if we put in negative 4, that is the absolute value of 2 times negative 4 minus 7, is that equal to 15? That's the absolute value of negative 8 minus 7. Is that equal to 15? Okay, yeah, this is going to work out too. This is the absolute value of negative 15. Is that equal to positive 15? And the answer is yes. So yeah, these are both solutions. They're the only solutions. But again, this is our strategy. We need to get rid of the absolute value symbol, and to do that, we break it up into two separate equations. For example 2, we're going to look at another absolute value equation, just one that is slightly more complicated. It's now an absolute value equal to another absolute value. But the good news, our strategy is not going to change very much. We're still going to get rid of the absolute value symbols. So I have this fact up here. To solve an equation of this form, the two equations are going to be, just let the two things equal each other. So just let a equal b. Likewise, you can let a equal negative b like we've been doing before. The reason this works is because, like, let's take a number for example, like the absolute value of 3. What would you put here to make this thing a true statement? Well, one obvious choice would just be to put 3 in place of that green question mark. The absolute value of 3 is equal to the absolute value of 3. Like, clearly that's going to be true. But another possibility would be, well, if you put negative 3 in the other absolute value, it's also going to work. Like, this gives us a solution, but so does this. Said in a different way, looking at the problem that appears here, I'm just going to let these two things equal each other. That's going to be exactly like doing this. That is, I'm going to let 3 plus 2x equal x minus 4. My second equation is going to be to take this thing and let it equal the negative of this. And that's kind of looking at this case over here. That is, 3 plus 2x is equal to the negative of the other side. These are the two equations we're going to set equal to each other. Let one equal the other, and then let it equal the negative of the other side. All right, so to solve, let's say, this equation, I'm going to subtract 3 from both sides. So I get 2x is equal to x minus 7. Then I'm going to subtract x from both sides, and I get x is equal to negative 7. So here is one of my solutions. My other equation is not going to be too different. I just have to distribute this negative into the parentheses. So I get 3 plus 2x is equal to negative x plus 4. So now I'm going to, I guess I'll subtract 3 from both sides, which gives me 2x is equal to negative x plus 1. But now I'm going to add x to both sides, and I get 3x is equal to 1. To get x by itself, I'll divide both sides by 3, and I get x is equal to 1/3. That is a different solution. But these are two solutions to this original equation, and we got that by breaking it up into two separate pieces, and that is it for this example.